11, we're going to talk about composition of functions today. All right. This is the plan for the next couple days. Today we're going to go over this section, and tomorrow you're going to have a homework check due and have some time to work on this section. Okay, because it's on next Tuesday's quiz. I do not plan to teach a new lesson tomorrow. I know you're all going to be homecoming oriented. Okay? Okay, but listen. On Monday, I'm teaching a lesson on inverses, which is functions that undo each other kind of thing. I don't know if you remember, if you have like 2x plus y equals 7, you switch the x and y, and then you get the y by itself kind of thing. Or you have a function like x plus 2 equals y, x minus 2 equals y would be the inverse, because obviously if you put one into the other, they'd cancel each other out. Okay, we're talking about that on Monday. But we're also going to spend part of Monday reviewing for a quiz, because there's a quiz Tuesday and I won't be here. I have to be in a meeting all day. Okay, so Tuesday quiz, it does not cover inverses, but it does cover this lesson today. All right, so 1.6 is adding, subtracting, multiplying, and dividing functions to form a new function. And it's also putting one function into the other, which is called composition of functions. The only trick, or the only hard part of this lesson, is the issue with the domains, okay? And this is really good practice because some of you really struggled with domain earlier in the chapter. It says, for the function, the domain consists of the intersection of the domains of the first two functions, and you have to exclude any values that make a denominator 0. So for each new function, the domain consists of those values that were common to the original function domains, unless it happens to have an additional restriction from having a denominator. Now, I know those were all just words and they went flying right over your head, okay? This, I found this slide this morning and I liked it because it kind of breaks it down pretty simple. It says, basically, if you have a polynomial, whoa, what's happening here? I don't have a pen. If you have my slate is not happy. Yeah, it's really big though. Okay, if you have a polynomial function of any kind that doesn't have a radical or a denominator, the domain is just all real numbers. That's it, guys. If you have a function that has a variable in the denominator, you set the bottom equal to 0, and then you say x cannot equal that, or it's all real numbers except that. Okay? The third option, if you have a function with a variable inside the radical, then you set the radical, whatever's in there, okay, the terms inside there, greater than or equal to 0, and I don't know if it says that. It should be greater than or equal to 0, and you solve that, and that's your domain. So those are the only three options. All real numbers. If there's an x in the denominator, I set the denominator equal to 0, and I say can't equal that. If there's a radical, I say what's underneath the radical has to be greater than or equal to 0. All right. The notation. This notation just means to add two functions together. This notation means to subtract them, distributing through the second one, the negative, okay? This means to divide, put f over x, and that's when you might have an extra restriction, right? Because the denominator can't equal 0. This is the one students sometimes struggle with because you have to read it really carefully. If it says this, sometimes people get it confused with this, which we're going to talk about in a minute. This means f of g, which means put g into f. If it's a solid dot here, it means to multiply f times g. If you are ever confused, you have a quiz question and you're like, you can't really tell, is that filled in, is it not filled in, am I supposed to be multiplying or putting one into the other? Ask me, I will clarify, okay? I'm not out to trick you. I'm not going to make half full circles, make little true false ones where my T looks like an F, and I'm going to tell the teacher I really meant F or T, right? Did you do that? True, false? No? Nobody ever did that?
Oh, I do it all.
Okay. All right. Not a big fan of true, false either. You know what? In math, it's not as bad as it seems because you can be pretty straightforward. But yes. Yeah, you can.
Like English, true, false is the freaky. Okay, this is not.
Okay.
Let's not.
All right, let's not go there. Yeah, okay. Here's an example. Why am I missing half of this? I'm still confused. Is that the whole problem? Okay. Where's the original top of the problem? All right, it's an example. Anyway, they've added two separate functions together, combined like terms, got this. It's all real numbers. Okay? I feel like I'm missing the top of the question. Okay. Here's part B. Here's part B. Obviously. Stop. I don't know what's going on. Why does this always happen? Okay. This one says find f divided by g, so all we do is take this and divide it by this. X squared minus 6x minus 6 over x plus 2. There is a denominator though. So it says x cannot equal what?
-2.
Or if we had to write it in interval notation, it would be everything except -2, like this. I'm fine today, just write x cannot equal -2, okay? This question in and of itself, though, doesn't reduce. Did I lose anybody? That's supposed to be a 1x. I don't know what I did. Right? It was a 1 right there? Okay. It doesn't reduce, like you can't cancel any of the x's, but it does reduce because it factors.
It does reduce. She says she wasn't trying to trick us. I'm sorry.
You're right. I'm just very frustrated. I don't know what to do with this tablet at the moment. This is x plus 2. Okay, the denominator is x plus 2. Try to turn this back on and see if it works. Then this entire factor will cancel. So we are left with f divided by g is just x minus 3 because it reduced out that whole factor very messily because my pen isn't working. But if you did not already do the domain, wouldn't you be confused? There's no denominator left. Okay. You have to remember that anything along the way that had a restriction still has a restriction. So this x can still not equal 2. It's a line with a hole in it, guys. If you graphed it, we'll talk about this later in rational functions in chapter 2, but because it factored and something canceled out, we still have to say x cannot be -2. Probably not going to be on the quiz like that, okay? Now, let's try these together. Ready? It's not. All right. F minus g is take. No, it's not. And I'm very frustrated.
Being positive.
Then I'm not by the microphone for recording, so I can do that, but I have to like scream.
I like screaming.
Oh, or I could just put your grades on record. Jeez.
Everybody pauses the video. Wait.
All right. F minus g. No, I can edit it out later, but
It's all good. It's all good. Well, I don't know. I might have a C.
f minus g is x squared minus 3 minus 1 over x. I'm not going to simplify that. I'm not going to mess with it. What is the only restriction on the domain? Okay, the denominator can't equal 0. That's it. This is f times g, so I have x squared minus 3 times 1 over x. You could write this a whole bunch of different ways. This is basically over 1, so if we multiply the tops together, we get x squared minus 3 over x. Tops and the bottoms together. X can still not equal what? You could also have written this as x squared over x minus 3 over x. This would have reduced to x minus 3 over x, and I would have accepted that answer. They're equivalent, okay? I'm not going to be picky about how you write it. All right, this one we are supposed to add, subtract, multiply, and divide these two functions, all 4. All right, so what will it look like if I add? Guys, this is not hard. No, it's supposed to say f plus g. What will it look like if I add?
X squared minus 1 plus 2 over x.
Yeah, I don't care what order you write. X squared minus 1.
Whoa, that's a 2.
This was supposed to be a plus. This one was supposed to be a plus. This one is a minus. Well, I'm just making up stuff now because I'm trying to catch up with the fact that I'm behind and not figuring out why this isn't working. Everybody okay? You just added on the first one, subtracted on the second one. X can't be 0. I haven't totally lost anyone yet. This is where it gets a little tricky. We're going to multiply them together. X squared minus 1 times 2 over x. You could write this a whole bunch of different ways, and it would be right, okay? If I multiply them together into a single fraction and I distribute the 2, I would have 2x squared minus 2 all over x. If I left the 2 out, not distributed, I would have this. If I factored that further, right, I'd have an x plus 1 and an x minus 1. I don't care. Any of them are fine. There is still a restriction, though, that what? No, I don't care.
X cannot equal 0.
Yep. All right, and the really weird, tricky one. Yes. If we write f over g, we get x squared minus 1 over 2 over x, which means x squared minus 1 is being divided by 2 over x. What do you do when you divide fractions? Okay, you multiply by the reciprocal. So this one is being multiplied by x over 2. If we distribute this through here, we do get x cubed minus x. Or you could leave it factored out, I don't care, over 2. This has no restrictions, but did something earlier have a restriction? X still cannot equal 0. Because the original function, you can't put something in the new domain that wasn't in the original domain, okay? There are not a ton of questions on the quiz where I ask about domain even, okay? Just to reassure you that I'm not going to ask it on every single question. All right. So these are weird ones again. If we have f plus g, this is not bad. We get x squared plus 4x minus 7 plus the square root of x. What's the restriction, though, when x is in a radical? Can't be negative. How do we write that? Yeah.
But I like to make it more complicated.
Okay, that's supposed.
It's beautiful. It's beautiful.
It's a square bracket 0 to infinity with a parenthesis. I don't know what's going on. Okay. Now we're going to do minus. It's just x squared plus 4x minus 7 minus square root of x. In the same, yes, see if I can write it any better this time. There we go, that looks a little better. All right, this is the one that messed everybody up earlier today. If we multiply these together, and I'm actually going to write this one out in front because it seems to make more sense to students when I distribute. But The question students had was, does multiplying this by this cancel that out? Okay, so square root of x times x squared, you're saying should be x? Is that what you're thinking?
Because x is 1.
If I put this square root of 4 times 4 squared, okay, square root of 4 times 4 squared would be what? 2 times 16 would be 32, yes? 2 times 16 is 32. Is that the same as putting a 4 in here?
Apparently not. Yeah.
Very good point. Do you remember that square root of x means x to the 1/2 power? And this is x to the 2nd power. So you could put x to the 3/2 power. As far as I'm concerned, you can just write x squared square roots of x plus 4x square roots of x minus 7 square roots of x.
So it's this, but this one,
Yeah. Well, we haven't talked about rational exponents. It's in the next chapter, like fractional exponents. So I'm just going to let you write it like that. What is the restriction on x, though, still? It is the same, greater than or equal to 0. How would you factor it? It would go back to what we started with.
Yeah, you could take the square root of x out and then we started with.
Maybe in one.
Oh, okay.
Okay.
She's done.
Talking loud. Screaming at the microphone. All right, guys. So this is still 0 to infinity. Is it off? It is. Okay. We have left to do f divided by g. If we write that messy f over g, I am not going to make you rationalize, in other words, multiply by square root of x over square root of x. It's an x. I mean, if it was a square root of 2, we'd deal with it. But a square root of x is just going to get back to that disaster we had a minute ago. It's just really messy. Oh, it does change the restriction. Does anybody know how it's going to change the restriction?
It can equal 0.
Yes.
It has to be just greater than.
Perfect. It still has, because it's under the radical, it would be greater than or equal to 0, right? But it's in the denominator, so it can't equal 0. So it's just going to be greater than 0. So all it changes is that. That make sense?
Yeah.
Anything under the radical has to be greater than or equal to 0. But because it's in the denominator, the rule is it can't equal 0. So we got to get rid of that little guy and just say greater than. Okay? All right. Compositive function is when we put one into the other. This is read f of g. It means we put g into f. The old school notation for that was that you take g, you put x into g, then you put that all into f. I don't know who decided we now have to write it like this. Somebody getting more money than me. Okay? This means the composite of f into g, or it's read g of f. Okay? I know some of us say fog and goth. Okay? And I really don't care. I really don't care. But properly, this is f of g. And I know there's some teachers who are like, you must say it correctly. This is g of f. But what does this mean you're doing? Putting what into what? F into g. Everybody okay? You do it kind of backwards of what it seems. When you do this, okay, you have to do the same thing for the domain. You can't make it bigger, so you have to put the same restrictions. And this, the bottom here, it says, in the composition f of g, which is read f composition g or f of g, the function g is applied first and then f, okay? So here, you're doing it backwards. G, F. All right, this one's done for us. It says put G into F. So this was F, and this was G up here. So they put all of this in here, and it became this. This is when everybody gets wrong. Why? They want to distribute a squared. There's no such thing. 4x plus 2 means 4x plus 2 times 4x plus 2, which becomes this whole thing, and then they distribute it and combine like terms. All right? I put this on this slide because there was a little room here. We're going to talk about this in a minute. When you have to put 2 into G, and then you can put that into F to solve that, okay? So you can put the 2 into G and then that value into F. Or, like we just did up here, you could find this whole F of G and then just put 2 into that. So I could put a 2 in here, or I could put the 2 back here into the G and then that answer into the F. It's the same thing. And I'll show you on an example. That's exactly why I usually do it 2 into G and 2 into F. Because if I messed up calculating the new rule, then when I put the 2 in, I'm going to mess it up. And it really should be the easiest question ever to put a number in, right? Okay. So sometimes I do it both ways just to make sure. Okay, so this one says, and it won't usually say this on a test or quiz, it's our hint on this one, we're putting F into G. So this whole mess has to go in here. So I'm writing down function G, and then I'm plugging in X. Okay, can you distribute and simplify? Minus 4 plus 2 would be minus 2. Okay? That's what they wanted us to find was the rule for this new thing. So don't factor something out. Don't try to divide. There's nothing to divide by because we only have one expression, not an equation. Just leave it. Any restrictions? Nope. No denominator, no radical, right? Anywhere along the way. We're good. All real numbers. The directions up there. Oh, we already found the first one, right? This was the second one? Okay. Moving on. More practice. Okay. We're supposed to find F of G, G of F, and F of G of 4. Okay. Anybody tell me what to do for F of G? So what does that simplify to? Everybody okay where they got the minus 7?
Yes.
We distributed here and got negative 8 plus 1 is negative 7. Any restrictions?
All real numbers.
So if I asked, would be all real numbers. Okay. G of F. So now this one is going in here. Which one's more likely to have people make a mistake?
This one.
Okay. It's pre-calc. I'm not going to let you leave it like that. Okay? Boiling this out.
You get 4x squared plus 2.
Combining like terms. What did you get, Marina?
4x squared plus 2. Unless I did that wrong.
I don't think the plus 2 is right if I remember right. This is a 4x and this is a minus 4x.
Minus 4 at the end of the.
Yeah, be really careful you show all your steps because you will do that. 1 minus 2 minus 4 is, I got minus 5. Is that what somebody else had? Because I distributed this right here.
I gotcha.
It's really easy to make a mistake on these, yes?
I just, yeah.
Okay,
Like I said.
still all real numbers? All right, this one says put a 4 into f of g. That's this first one, right? So I could put a 4 in there. What's the other option if I don't want to put a 4 in there?
Put the 4 in the G and put that into the F.
Okay, if I put a 4 into g of x, I would have 4 squared minus 2 times 4 minus 4. 16 minus 8 minus 4 is 4. Then I put that answer into f. 2 times 4 plus 1 is 9. Did anybody type that and get a 9?
Sure.
I did, you know.
This is 32 minus 16, which is 16 minus 7 is 9. Okay? You good?
Yep.
We have a denominator again. Okay? G into f. So we're going to have a 3, a 1 over x, quantity squared minus 4. We square 1, we get 1. We square x squared, we get, or x squared, we get an x squared. Okay. Where does that 3 go?
On the top.
Yeah, it's like a 3 over 1. So we end up with 3 over x squared minus 4. And I am not going to make you get a common denominator and simplify into one rational expression yet, because we haven't done that. So we're going to what can x not equal?
0.
Yep, x can't be 0.
Can we that makes it easier for us to
What?
can we put it in?
Yes, if you want to get a common
I don't
denominator,
know. I could see myself getting confused trying to find the
it is equivalent to 3 minus 4x squared all over x squared, if that makes you feel better.
Okay.
It's only one
If somebody wants to write that, I'm fine with it, but I'm not going to make you write it that way at this point, okay?
I'll just get confused if I don't do it every time.
G of f, yes, all of this is going in here, so it's, that seemed so easy, and it was so exciting how easy it was.
It was just fun.
Except now we have to figure out what's not in the domain, and it's a hot mess.
The square root of 4 over 3.
Awesome. 3x squared minus 4 cannot equal 0. 3x squared cannot equal 4. X squared cannot equal 4/3. X cannot equal plus or minus the square root of 4/3.
Oh, I forgot about the plus or minus part. Look at that.
What's the square root of 4?
2.
Okay. Woohoo! I am going to make you rationalize that one. What is that?
2 times the square root of 3 over 3.
Okay.
Is that really your favorite number, Claire? Really? I like the positive and the negative.
Okay. I think we're supposed to also say x can't be 0 because that was g back there. If we had to write that out in interval notation, it would take me 5 minutes just to read it to you, let alone write it out loud. Okay? I'm stopping there. There's not one like that on a test or quiz, all right?
The top bar, you're really
I do hereby solemnly swear.
Writing.
Got it?
Signature on it.
Okay, guys, let's finish this up. F of g of 4. Okay, remember we can just put it into our rule for f of g if we want.
3 over 16.
Type it on your calculator. Do a math, enter, enter. Jacob? Oh, okay, sorry. I I think that's right because I have magical fractional powers in my head. Would be -3 and 13/16. Or that's supposed to be over 16. Where did I get a 64? My magical fractional powers were. This was 64 over 16, so that's anyway. 4 with a common denominator is 64/16. You don't have, just type in your calculator right now. 3 divided by 16 minus 4, math, enter, enter. Is that not what you got? Divided by 16 minus 4.
It just doesn't exist anymore.
I squared the number. I put a 4 in here.
Okay.
Oh.
This was our answer for f of g. We good? We are going to skip a little bit in a second. We're going to do this problem though, because this you do need to know how to do. F of g means put which one into which?
The G into the F.
So we have 4 square roots of x plus 3 minus 2. Wait a minute. We did that yesterday. We talked about how to graph that recently, yes? Shift left 3, down 2, all that good stuff?
Class is cumulative.
Guess what the domain is? Guess what the domain is? That seem right?
Yeah, for sure.
You told me you would go left 3, down 2.
Oh, yeah.
Does that make sense that that's the domain?
Yeah.
So something we did yesterday and the day before tied to something we did today?
Whoa.
It's almost like this class is team.
Almost. Okay. What if we put the other way around?
That's kind of. I don't know what it is. 4x.
Yeah, if you leave that on your paper, I'm going to go -0.5. It's Precalc. You guys simplify. Okay, right at the top, simplify.
Is Precalc what? I'm in the wrong class.
It's not -5, it's +1. Okay, restriction on the domain.
X has to be greater than or equal to 1, -1.
Okay. Pause for a second. Try to think about this. The original restriction said -3 and up. The new restriction says -1/4 and up. Is this more restrictive or less restrictive? The blue one is
More restricted.
okay. Okay. The blue has included less values, yes?
Yes.
Okay. So that's the new restricted domain. Okay? Because we can't use any of this anymore. It's just this. We're good.
I'm glad we're good. I like being good. I don't be good at that.
Merry Christmas, happy homecoming. We can skip this question.
I love how you say that like it's a holiday.
Okay, we're doing this one. We need to do this one. Okay, G into F instead, horrible. What do we get? Did I do something? I did skip the F of 4 on the last one. Is that what I did?
We don't have to do it. We know how to do it. We know how to plug numbers.
If you put a 4 in here, what will we get?
Number.
Love and chug. True that.
4 square roots of 7 minus 2.
There you go.
Doesn't simplify. It's the exact answer. If you typed it in, you'd get an approximate decimal. Okay? But that's it. All right, back to this one. Restrictions, yes?
Lots of them.
I'm going with it doesn't stay, so let's go with no. If we did,
Let's go with no.
okay, yeah, whatever.
Not important.
It also couldn't equal 1 back here, right?
True.
Okay, I'm not gonna ask you one like that. Let's keep going. G of F. G of F. This into here this time.
You.
It's not that bad. Square the top and we get 1. Square the bottom carefully.
X squared plus 1x minus 1x.
Squared minus 2x minus
Minus 2x. What am I doing with my life? Sorry, Mom.
I'm fine with you leaving it like that. What value can it not equal? Way back here. We're supposed to put a 4 into G, and then that answer into F. Or we could put our 4 into our rule right here.
Let's do that.
If we put it here, we'd have what? $114?
Good job, Katie. I'm proud of you.
All right. You don't have this on your, I just need you to pay attention up here. I thought this was what the homework asked, but it's not. But we're going to do these anyway, and then I'll do what the homework actually asked. But there's some about graphing on your homework. Guys, on your homework, on section, it's on the gold sheet, but here, all of these questions are just looking at a graph and writing down an answer, okay? That's all those are. You don't have very many, and then you have these, but they're just looking at a graph and writing down an answer. I was thinking they were this kind of question, and I think I was wrong because Kate just told me what they are, but let's practice this anyway. I asked you to do G of 2 on the quiz last time. Look at a graph, evaluate the value at 2. G is the green function. What is its value when x equals 2? So this is a -4. If you were evaluating the composite, then you would put that into into F, I'm sorry. Function F is the red one. Where is it at -4? I lied, it's all the way down here. -9. All right, so help me with this one. See if you can do it without me scribbling all over the graph. If you can see well enough. H of 5, H is the blue one.
-6.
Okay, that looks like -6, yes? Then we're putting that -6 into G. G is this guy. Where is he at -6?
4.
4?
Yeah, I did.
Put a 5 into H, the blue one, and at 5 he was equal to -6. Put the -6 into G. The green function, I'm sorry, at -6 is equal to +4. Okay?
Not emotionally, mentally, not even spiritually.
All right. I'm going to go to this one, because then we're going to do what's actually on the homework. G of F. This means the same thing, it's just different notation, yes?
Yep.
A -7 into F. Which one's F?
The red one.
The red one. -7.
0.
Is that spot right there? So y is 0. Now I'm supposed to put a 0 into g. G is the green one. Where is it? When x equals 0, y is equal to? So this would have been -2. Okay. That was great practice until I realized that that isn't even what the homework asks.
Oh, wow.
The homework's really easier because the homework says this. Does anybody know what that means? Put a 2 into G and a 2 into F and add them together. Okay, so a 2 into the G function would give me out -4. Everybody okay? A 2 into the F function doesn't exist. That was really helpful. All right. Can I do H instead?
You can just do -2.
Was that F? Let's change this to an H. H of 2 is 0. So you'd add them together and get -4. But all it is reading the graph, finding the values, and then doing whatever operation is in the middle. Okay? So those are really nice, easy questions. There's no work. You just look at the picture and write down your answer.
Same thing.